Welcome to this hands-on exercise, where we will detect and handle outliers using two popular statistical techniques, the Z-Score method and the Interquartile Range, or IQR, method in pandas. We begin by setting up our sample dataset with injected outliers. The code generates 100 synthetic samples for height, weight, and income using NumPy. Then, a few extreme values are manually inserted into each feature to simulate abnormal data points. A pandas data frame is created from this dataset, and we display its shape and the first few records to verify that the data, along with the outliers, is loaded correctly. Let's run the code. You can now see the dataset, which includes clearly visible outliers in all three columns. Next, let's visualize the raw data. This section generates boxplots for height, weight, and income. Each plot is displayed individually to give you a clear look at the distribution before any cleaning steps are applied. Let's run it. A box plot, also known as a box and whisker plot, summarizes a dataset using 5 key statistics: the minimum, first quartile, median, third quartile, and maximum. The box spans from Q1 to Q3, with a line marking the median. Whiskers extend to the smallest and largest values within 1.5 times the interquartile range. Any dots or points outside the whiskers are considered outliers. From these plots, you can see that the height column has 3 outliers, one near the top at about 250, another just above 150, and one around 10 at the lower end. The weight column also shows 3 outliers, one around 200, one just above 100, and one at approximately 5. The income column contains 2 extreme values, one near 10 million and one at the very bottom. Now let's apply the Z-Score method to detect and remove outliers. Here, we drop any row where a numeric column has an absolute Z-score greater than 3. Why do we use the threshold of 3? Because in a normal distribution, about 99.7% of data lies within plus or minus 3 standard deviations from the mean. Anything beyond that range is statistically rare and more likely to be an outlier. Let's run it. Next, we visualize the results to check if the Z-Score method successfully removed the outliers. As you can see, the Z-Score approach failed to eliminate the extreme values. This often happens because Z-scores rely on assumptions about the data's distribution, and they can be heavily influenced by the very outliers they are trying to detect. When Z-scores fall short, more robust techniques, such as the IQR method, robust scaling, or isolation forests, may give better results. Now let's apply the IQR method. The interquartile range is a robust statistic that calculates the middle 50% of the data. We compute Q1, the 25th percentile, and Q3, the 75th percentile. The IQR is simply Q3 minus Q1. Values are considered valid if they fall within the range of Q1 minus 1.5 times the IQR, up to Q3 plus 1.5 times the IQR. In this step, outliers are filtered separately for height, weight, and income. Each column produces its own clean data frame, so a row removed for one feature may still appear in the others. Let's run it. Now let's visualize the cleaned results. As you can see, all 3 columns are now free of outliers. The extreme values have been removed, and the distributions appear well behaved. This exercise gives a quick comparison of the Z-score versus the IQR method. Z-score works well when your data is roughly Gaussian, but it is sensitive to the mean and standard deviation. IQR, on the other hand, is much more robust to skewed distributions and extreme values, making it a preferred option for many real-world datasets.